Welcome to This Explainer. You know, if you've ever watched a pro athlete pull off some wildly complex physical feat and just thought, how on earth do they make that look so effortless? Well, you are in the exact right place. Today, we're diving straight into the really fascinating neurological foundations of athletic habit formation. We're going to pop the hood on human performance and dissect the precise mechanics of how sporting habits are actually built, hardwired, and ultimately perfected right inside the brain. Because as you'll see, it's really not just about muscle memory, it's all about neural reinforcement.
I want you to just picture yourself standing on a basketball court for a second. You can physically feel the texture of the ball in your hands, right? You hear the squeak of sneakers on the hardwood, you feel that heavy, tense silence of anticipation right before a shot. You line up a free throw, you release it, and the ball arcs and drops perfectly through the net. But what actually happens in that exact split second to guarantee you can do it again? What transforms that one deliberate action into an unconscious, perfectly executed routine? Okay, let's dive into this, because uncovering these hidden mechanics of physical mastery actually reveals something incredibly powerful about how all of our brains operate.
All right, moving right into our first main section, the athletic habit loop.
Let's break down the exact three-part sequence of practice. Now, everything starts with this sensory trigger. Step 1 is the cue. That's simply stepping onto the court or, just entering the venue. Your brain instantly recognizes the environment and preps for action. And this immediately triggers step 2, the routine. In our example, it's the physical act of actually practicing that free throw. You align your posture, you bend your knees, and you take the shot. But here's where the magic really happens. Step 3, the reward. This is the positive reinforcement, which is perfectly encapsulated by hearing that sharp, super satisfying swish of the net. This distinct sequence right here, cue, routine, reward, is the absolute foundational loop that builds all athletic consistency.
So what's happening underneath all that? That brings us to section 2, inside the brain, and a concept called action prediction error. Swish. I mean, it's such a visceral, deeply satisfying sound, isn't it? But neurologically speaking, it's actually way more than just the noise of a successful shot. That sound is the exact, precise moment your brain signals that a movement was a total success. See, when you practice a sport, your brain is acutely listening for this feedback. That specific auditory reward acts as this massive neurological stamp of approval. It's basically your brain telling your nervous system, yes, whatever we just did with our muscles, that was absolutely the correct action.
And this brings us to a highly specialized mechanism. The absolutely crucial point here is understanding a concept known as action prediction error. Put simply, this is the brain's internal system of measuring the success of a movement to solidify a specific behavior. Think of it as a secondary system that's just constantly working behind the scenes. Every single time you hear that swish, the action prediction error mechanism registers a positive hit. It evaluates the prediction your brain made against the actual successful outcome, and then, this is key, it uses that data to aggressively reinforce the frequency of your successful shots.
So you might be wondering, where does all of this processing actually take place? Well, the real hero of physical mastery is a region of the brain called the basal ganglia. This little area acts as the brain's central habit center. Now, what's really interesting about this is that when that basketball goes through the net, the basal ganglia physically processes this positive reward. Seriously, if we were looking at a live brain scan in that exact moment of the swish, the basal ganglia would quite literally glow with activity. It takes that success signal from the action prediction error system and uses it to lock the habit in. It makes the neural pathway for that specific throwing motion stronger, tighter, and way more efficient with every single successful repetition. Which leads us perfectly into our final section, achieving automated mastery.
And this brilliantly illustrates the real journey of an athlete. You see, it always begins with conscious practice. That's where you're highly aware of every single sensory cue, carefully and deliberately managing your actions. And honestly, it takes immense mental energy. But as consistent success signals keep hitting the basal ganglia, those neural pathways physically strengthen over time. Eventually, you achieve what we call automated responses. The movement no longer requires deliberate thought. It's been completely hardwired by that repeated positive feedback. Your brain has literally reshaped itself around the success of that action. It's amazing.
If there's one core takeaway I want you to get from this explainer today, it is this. Successful athletic actions become automated responses through repeated positive feedback. This specific neurological architecture is exactly why deliberate, focused practice matters so intensely. You aren't just building muscle out there, you are literally wiring your brain's habit center to automatically trigger perfection on demand.
Understanding this gives literally anyone the blueprint for applying the science of neural reinforcement to their own goals, whether you're on the court or totally off it.
We've seen how a simple sensory cue, a basic physical routine, and the rewarding swish of a net can physically alter the actual pathways in our brain. The mechanics of sporting habits show us that excellence is definitely not an accident. It's a neurologically reinforced inevitability. So I'll leave you with this final thought to chew on. Armed with this new knowledge of how action prediction error and your own habit center actually work, what successful habit are you going to wire into your own basal ganglia next?